Hey everyone, this is our quiz review. Here I'm going to work on the honors version of the quiz review, but if for the Regents classes, all that's different is just one extra question. So for you guys, the Regents classes, you don't have to go all the way to the last question here, but for the honors section, then you have to go all the way to the end. And let's start here with numbers 1 through 5. We're going to deal with constant velocity, acceleration, and some kinematic equations. On the flip side, there are some freefall problems and that relative velocity problem for the honors class. Alright, so let's start here. So we have a car moving with a constant speed of 20 meters per second. What total distance does the car travel in 2 minutes? So when we're dealing with constant velocity, this is our only equation. V equals d over t. V is our velocity, so we have a constant speed of 20 meters per second. So V equals 20 meters per second. We're looking for distance, and our time is 2 minutes, which you need to translate into seconds. 2 minutes equals 120 seconds. So you plug and chug. $120 times 20 will get you 2,400 meters. That's your answer. Number 2, same idea. Truck traveling constant speed covers the 13 meters in 5-second interval. We need to find the speed, so that's a question mark. 13 meters over 5 seconds. This should turn out to be 2.6 meters per second. There we go. Next, when we have acceleration, that's when we start to use the other 3 equations. But this is the initial equation we learned for acceleration, where A is equal to delta V over T, Vf minus Vi, the same as delta V. Alright, a car increases its speed from 9 meters per second to 15 meters per second in 4 seconds. We're looking for the average acceleration. Alright, you had to read the problems carefully. It starts from 9 and it goes to 15. You also want to keep an eye out for those units. Meters per second is your velocity unit. Meters per second squared is your acceleration unit. That's the difference between those two. So this turns out to 6 over 4. This is 1.5 meters per second squared. Alright, next one. A car initially traveling at a speed of 60 meters per second accelerates uniformly to a speed of 20 meters per second over a distance of 36 meters. What is the magnitude of the car's acceleration? We have our 3 kinematic equations. The first one is essentially a rewrite of the blue equation above. And this one. It's initially traveling at this speed, accelerates to a speed, so it's going from 16 to this other speed. Careful, that's not your acceleration. Carefully read this. Accelerates to this speed. This is your Vf now. Over a distance of 36 meters. So we don't know what A is. We have D as 36 meters. We have a speed initial of 16 meters per second. That's a 16. And Vf equals 20. So you look at what you're given. We need A. You have D, we have Vi, and we have Vf. Therefore, we have to use this guy. We have this, we have this, we need that, and we have this. So you should be left with only a single variable to be looking for. If we look at this second equation, D, we have that, we have Vi, we don't have T, and we also don't have A. We can't be left with 2 missing variables, so that rules out the second equation. And this one here, again, we don't have T, and we have D, so we need to use D for this one. So we can't use the first one either, which leaves us with the third equation. Oh, let me use purple. Alright. Alright, so this comes out to okay, I'm going to do the math in another color. So this is 400 equals 1, that's 256, I believe, if I recall this. No, I am doing this wrong. Oh wait, it is actually 256. Alright, plus 72a. You subtract 256 to the other side. Let me do this off to the side right here. You should get 144 equals 72a. Divide both sides by 72 and you get that a is equal to. Alright, so our answer here is a is equal to 2 meters per second squared for that question. Alright, that wasn't bad. Now number 5. Let's go back to purple. A truck initially traveling at a speed of 22 meters per second, that's your VI, equals 22 meters per second, increases speed at a constant 2.4 meters per second square for 3.2 seconds. Alright, this is the tricky part. It increases speed at a rate. So that's your acceleration rate. It's not increasing to that, it's increasing at that rate. And if you look at the unit, meters per second squared, that's your unit for acceleration. Alright, 3.2 seconds. What is the total distance? So D is what we're looking for. Alright, so what that means, we're going to use the middle equation. D is what we're looking for. So we have 22 meters per second times 3.2 seconds plus 1/2 2.4 meters per second squared times 3.2 seconds squared. Alright. So you plug and chug and you solve, so you should get your distance. 82.7 meters is your answer. Alright. Now we move on to the back of the page where we have our 3 free fall scenarios. Object drop, object thrown down, object thrown up, and that 1D relative velocity problem for the honors class. Alright, so you should expect to have a question on the quiz for each of these categories. And so let's start with number 6, where we drop an object. Let's do color blue. A rock falls from rest. Remember that in the initial velocity is 0 meters per second for our dropped objects. Vertical distance is 0.72 meters. Surface of a planet, and t equals 0.63 seconds. We are on a different planet than Earth, so our acceleration will not be 9.81. That's only valid for Earth. So we're going to use this equation. Alright, plug and chug, find your acceleration. You get 3.63 meters per second squared as your acceleration. Alright, now with an object thrown down, your initial velocity won't be 0. This time you're giving it an initial velocity. You're thrown straight downward with the speed of that. And the height of the building is 16 meters. But we're looking for the speed of the ball after this time. Okay. So we don't know for sure whether or not it took 0.5 seconds to cover the entire 16 meters. So what we're going to do is just ignore the distance and focus on the time, because that's what the question is looking for, specifically how fast it's moving after 0.5 seconds. But hey, are we missing something? We need the acceleration. And what is it? 9.81 meters per second squared, because now we're back on Earth. If they specifically say a different planet, then we can't assume it's 9.81. If any other problem, we can assume 9.81 because we're assuming we're still on Earth. All right. We got VI, we got T, we got A, and we're looking for VF. We could just use this one. All right, now plug and chug. You should get 6.91 meters per second as your answer. All right, object thrown up. This is a different beast entirely. Let's use green. A ball is thrown vertically upward with an initial velocity of 29.4 meters per second. Like the thrown down option, a scenario, you're giving it an initial velocity. Acceleration will be a negative 9.81 meters per second squared, because now we're going up. We're working against gravity. That's why we make it negative, because we're working against gravity, which will cause the ball to slow down. So in scenarios where you're slowing down, it's easy to make your acceleration negative for the ease of calculations to ensure you get the right numbers. Because if you make it positive, it's going to cause a big issue. Now, final velocity, when you throw a ball up, it starts from it starts and then it ends at the peak. At the peak, objects slow down to a stop. Because for these equations, we can only work in terms of going from start to finish at the top. But if you want to figure out the other way around, going from top to bottom, then you got to flip it around and work with other equations that way. We can only solve it in terms of one way, so going from the bottom to the peak, we take our VF as 0. We're looking for the maximum height reached by the ball, so the distance it takes from where it starts to where it ends at the top. And then we are also looking for the total flight time. That will be for part B. So for part A, we're going to use this equation. Alright, when you plug and chug, you should get your answer to be 44.06 meters for the maximum height. So you throw the ball up, and it comes back down to where you started. But this height right here from start to the peak is 44.06 meters. And now we're looking for the total flight time going from start all the way back down to finish. So we can only solve for the time going from the bottom to the top. So from there, after you do that, you just double it, because this is symmetrical motion from bottom to top to bottom, equal but opposite in direction. All right, now let's pick a different color and let's make it purple. All right, so looking for total flight time, we can use any equation we want as long as it has t. So I'm going to go to this one. Okay, so that's an equal sign. And t, so you solve for t and you get practically 3 seconds for going up. The total time now is 6 seconds. That's our final answer right there. Alright, now we've reached our final question right here. It's for the honors class, relative velocity. So here I am rowing a boat across the lake with a speed of 2.5 meters per second relative to the river against the current. relative to the shoreline, the river is moving 0.75 meters per second. What is my speed relative to the shore? So I'm on a boat. And I'm going, if the river is going this way, that means I'm going this way. So I'm going 2.5 meters per second that way. Relative to the shoreline, the river is moving 0.75 meters per second that way. This is relative to the people on the shore. What is my speed relative to the shore then? Okay, so if we remember, I'm going to use B for boat, R for river, and S for the shore. We are looking for my speed, the boat speed, relative to the shore. The speed of the boat relative to the river going against it is negative 2.5 meters per second. Relative to the shoreline, the river, according to the shore, is going this speed. So when we set it up, we got to make sure that what we're looking for is on the outside. And then the third variable is being canceled out. So VBR plus VRS. We're looking for B and S, so B and S have to be on the outside, while the third one right here has to be in the middle, canceling each other out, like that. Okay, now when we plug in chug, VBR is negative 2.5 meters per second plus 0.75 meters per second, and you should get a negative 1.75 meters per second. That's how it looks like I'm going according to the people on the shore. So people on the shore right here will probably see that I'm going this way overall. Even though I'm steering the boat at 2.5 meters per second, it looks like to the people I'm moving 1.75 meters per second. Alright. Now, if you're still stuck or need some additional review, feel free to check out the topic review videos. There's one on 1D kinematics, I'm going to post some on Freefall, and a little bit on 1D relative velocity. Stay tuned for those.